All right, multi-step synthesis. Now, we worked out a retrosynthesis, and I've left one of our retrosynthetic pathways up here so that we can then work in the forward synthetic reaction. The other one, which is in the other video, you should take and you should work out on your own. So, now, how do we affect nitration of toluene? If you remember, the conditions were HNO3, nitric acid, and H2SO4. This will produce, as major products, the paranitro and our desired orthonitro compound. Now, in both, in this case, both will be produced, and we can probably fractionally distill these or fractionally crystallize them if the melting points are sufficiently different to obtain the desired one. And you should maybe, I want you to recognize that you need to do separation here. Now, again, at this level in this course, we're not going to ask you to know the detailed temperature, column length, etc. to fractionally distill or fractionally crystallize these, but to recognize I've got to separate those two isomers to have the correct one that I need. So, I want you to recognize and indicate that we need to do a separation, but the details of that we'll save for a more advanced course. So now let's assume that we've been able to separate our desired isomer. We need to do one more thing to get to the desired product, and that's bromination. And the conditions here will be FeBr3 and Br2, and under those bromination conditions, the bromination should give us as the major product our desired compound. There may be a little minor with substitution over here, but we can separate that easily enough as well. But when it's a minor product, we're not going to worry about it. And again, remember, it's the steric congestion of that methyl group ortho to the hydrogen that will reduce substitution at that position typically.